Am I audible? Am I audible? Okay. So in the last class, we have seen few examples on the source transformation. Today we will look into the source shifting, okay, which is one of the important technique in circuit reduction. Okay. So we will look into the source shifting. Analytical part of this is already been discussed, okay, in the one of the previous class. We'll look into directly the example. Okay. So okay. Uh, Using source transformation and source shifting, find the voltage across 2 ohm resistor. Okay. Using source transformation and source shifting, find the voltage across 2 ohm resistor. Okay. In the circuit shown below. In the circuit shown below. Voltage across 2 ohm resistor. That I need to find out. The circuit given is 3 ohms.
Sir, only half of the circuit is visible, sir.
So this is the circuit given. I need to find out the voltage across this 2 ohm resistor. That is the question. Okay. Now I have to go for source shifting. Now there are two sources given here. 2 ampere current source and 5 volts voltage source. Okay. So if I have to take the source shifting of current source, then I will be shifting this current source of 2 amperes across the parallel branches to this source. Now the branches which are parallel to this source are 5 ohm and 2 ohm. And after shifting this current source across the parallel branches, I will be keeping this branch open because I am taking out the source from this branch and keeping it across 5 ohm and across 2 ohm. Therefore, the branch whatever in which the current source is existing originally should be taken out from the circuit. That should the current in that branch should be made zero. And when I have to make the current zero in any branch, that branch I should be taking it as open circuit. That branch I should be taking it as open circuit. Now, here I have a voltage source. Now this voltage source has to be shifted beyond the node. Okay, this voltage source has to be shifted beyond the node. Now I can shift this 5 volt voltage source beyond this node, or first let me first name the nodes A, B, C and D. It will be easy for us to talk. Now if I want to shift this 5 volt voltage source, I can shift it. Okay, I can shift it beyond the node C in series with 4 ohm and 3 ohm, obviously with respect to the polarity, or I can shift it beyond the node D in series with 2 ohm and 2 amperes. But one problem with shifting of this 5 volt beyond node D is that a current source and voltage source will come in series. A current source and voltage source will come in series, and both are ideal sources. Okay, analysis may become a little bit complex. Okay, and moreover, I want the voltage across 2 ohm. Then when I shift this 5 volt into or beyond node D in series with 2 ohm, I will be forced to reduce this circuit with 2 ohm. Okay. In future analysis or in further analysis simplification, this 2 ohm may get merged into some other resistor. So till the end, my 2 ohm resistor should be intact. It should not change its position in the circuit or its value in the circuit. It should be as 2 ohm. So what I can do now is I can shift this 5 volt voltage source beyond node C. Okay, that is the easiest way what I have to go to solve this particular example. So first what I will do, first I will shift the current source. Okay, now shift current source, shift 2 ampere current source, okay, across 5 ohm and 2 ohm resistors. 5 ohm and 2 ohm resistor. Now how I have to shift? There is one thumb rule we have discussed, that whenever I am shifting the current source, we should be observing the original nodes to which the current source is connected. Now the original nodes to which the current source is connected is node A and node D, and observe the current of this source, how it is entering or exiting this nodes. Now current 2 ampere is entering node A and it is leaving node D. So when I shift this source across 5 ohm and 2 ohm, the direction should be such that the current 2 ampere should enter node A and it should exit node D. Okay? So that has to be done in the way shown now. Now for a moment I will keep voltage source as it is. We can take both source shifting simultaneously, no harm. Okay, but it should not confuse you people. I am taking one by one. Okay. So here it is 3 ohm. I will write simply the values. Implicitly those are always in ohms. 5, 4, 2 and 5 volts. Okay. Now current 2 amperes is entering. Now I have a current source across 5 ohm. Okay. I have a current source across 5 ohm. And I have a current source across 2 ohm. Now at node A, the current should enter. There should be entering current. So this is 2 amperes. And at node D, the current should exit. This is 2 amperes. And the original branch where the source was originally situated. Now this branch is to be kept open because now I have taken the source from this branch. I have taken the source from this branch and I have shifted it to some other branches. Therefore, the source value in that branch becomes 0. And when the source is a current source and the value of that current source, when it has to be made 0, then I should be taking it as an open circuit because in current is 0 in open circuit. Okay, and when I shift the voltage source beyond the nodes, I need to make the source value in that branch 0. And when does the voltage value becomes 0? When there is a short circuit. So when I replace any branch or when I transfer or shift the current source, that original branch must be made 0 open circuit, and when I shift the voltage source, the original branch must be made short circuit. Okay, that is the concept. The fundamentals you should not forget. When there is open zero current and when there is zero voltage, what is the circuit condition? Okay. So this is one case. Okay. Now in second stage, I will shift the 5 volt voltage source beyond the node C. Now observe, node C is at positive potential. Because node C is at positive potential with this source, 3 ohm is at positive potential connected to node C, 4 ohm is at positive potential connected to node C. Now, when I shift this voltage source beyond the node C, I should make sure that the terminal potential of the resistors connected to that particular node should retain the same polarity, not of the node but of the element. So now when I shift this voltage source beyond the node C, I should be shifting in such a way that 3 ohm is at positive potential with this terminal, 4 ohm is at positive potential with this terminal. Okay, that is my requirement. Now next, shift 5 volt source beyond node C. Shift 5 volt source beyond node C. Okay, so when I do that, now the original branch containing the voltage source should be replaced by short circuit. So this should be replaced by short circuit. Now this should be at positive potential, this should be at positive potential. Okay, 3 ohm and 4 ohm. Now the polarity of the source will be like this. 5 volts and 5 volts. So this is how source shifting has to be done. Okay, and here I have a current source of 2 amperes. Of 2 amperes. Now once the shifting is done, the rest part is only the source transformation. Okay. So what I can observe here is, I should be keeping this 2 ohm resistor as it is. Now I will not touch this 2 ohm and 2 amperes. I will keep them as it is. Okay. Then I will convert this 5 ohm and 2 ampere current source into a voltage source. Right? That can be done. Okay. I want only the voltage drop across 2 ohm. I will keep it intact. I won't change anything in that branch. Now, I will convert 2 ampere 5 ohm in branch AB into a voltage source. Now, if I do that, then I will get 2 voltage sources in series, 5 volt 3 ohm and 5 ohm 2 ampere when converted to voltage source. These two will come in series. So that will be easy for us for simplification. Okay. So now you take next. Convert or transform transform 2 ampere 5 ohm source into a voltage source. Into a voltage source. Now when I do that, okay, so first I will draw this 2 ohm. This is 2 ohm and 2 amperes. This is node D. Now this is node B. Okay. This is 5 ohms. Okay. And observe the direction of 2 ampere source. It is away from node B. So the positive direction should be away from node B. Okay. So let this be V or V1, okay, which is in series with 3 ohms, okay, and 5 volts. This has come here. Now from node B to node C, there is one 4 ohm and 5 volt. Now this is the rear-ended circuit. Okay. Observe here the direction of the sources. Okay, once transformed from the previous one is very important. Okay, that should not get altered. That should not get changed. Okay. Now the direction you observe. Now here this is node A. Node A is connected with 3 ohm. This is node point A. Now I cannot call it as node. Now I can call it as terminal. Okay. So here the direction of current is towards terminal A or node A in the previous circuit. Therefore, the positive direction of the voltage source will be towards terminal A or node A. Okay, that is that has to be maintained. Okay. So now convert. Now you take the equivalent value. Now what is V1? I will get V1 here. V1 is equals to, okay, it is 2 amperes into 5 ohms. So this is V1 is 10 volts. So my value of V1 is 10 volts. 2 amperes into 5 ohms. Value of V1 is 10 volts. So this is 10 volts. Now I have two voltage sources in the same branch connected in series, okay, but opposing each other. Now the direction of 10 volt is like this. Direction of 5 volt is like this. So the equivalent voltage in this branch is 10 volt minus 5 volt. And resistance is 5 ohm plus 3 ohm. I will take out this. So this is node B. Now the direction of potential difference, or sorry, the source is the direction of higher value. Plus this is 5 volts. This is 8 ohms. 5 ohm plus 3 ohm, 8 ohm. 10 volt minus 5 volt, 5 volts. Okay. So this is the new reduced circuit. Now we have two voltage sources in parallel. Okay. Or what I will do is I will redraw this circuit. Okay. See, this is same connection. This is node D only. I will simply shift this. When I redraw this circuit, it will be, because it will be easy for us to visualize and understand. Okay? Observe the polarities. Don't forget that. Now this is what node C. Now node C and node D are directly connected with a wire. Now this is node C, node D, and this is node C. Okay. So node C is connected with negative terminal of this 5-volt source in series with 4 ohm, and positive terminal of this 5-volt source in series with 8 ohm. Positive terminal with 5-volt source in series with 8 ohm. So while reducing the circuit, while transforming and shifting, the direction of polarities is extremely important. Now, two voltage sources are in parallel. You convert that into the two current sources, because I cannot solve these two voltage sources in parallel directly. We know that. So now we have to convert these two voltage sources which are in parallel into the current sources. You can take convert both voltage sources into current sources. So now this is 2 ohm, originally 2 ohm, and this is 2 amperes. Now 5 volt 4 ohm will yield us one current source. Now the direction of 5 volt is upward. So the current source, when transformed from this 5 volt 4 ohms, will be upward. Let this be I1, which is in parallel with 4 ohm, this 4 ohm. Now I will get one more current source of this 5 volts, 8 ohm. 5 volt, this 5 volt is downward, therefore the current source equivalent to this 5 volt 8 ohms will be downwards. Let this be I2 in parallel with 8 ohms. Now find out the currents I1 and I2. Now I1 is equals to 5 volt divided by 4 ohms, 1.25 amperes. Okay. Next I2, 5 volt divided by 8 ohms. It is equals to 0.83, I think, amperes. Not 0.83. 0.63. 0.63 amperes. Okay. It is 0.63 amperes. Roughly, okay, it will come 0.625, I think. 0.625 amperes. So now this is 1.25, this is 0.625. Now both the current sources are in opposite direction. I can take the equivalent current source of 2 amps, 1.25 amps, and 0.625 amps. Okay, the equivalent current source of 2 amps, 1.25 amps, and 0.625 amps. Okay, so when I do that, take equivalent current source three sources, of all three current sources. Take equivalent current source of all three current sources. The resultant is I is equals to, okay, see, 2 amperes is upward, 1.25 ampere is upward, 0.625 ampere is downward. Now, the larger values of currents are upward, so I will take upward current as positive. There is no compulsion that upward current should be positive and downward current should be negative. There is nothing as such. Because the larger values are towards in the upward direction, I will be taking the larger values as positive values. Generally, we do this. Okay, so it will be 2 plus 1.25 minus 0.625. So this is equals to 2.625. It is 2.625. Direction is upwards. So now I will redraw the circuit with 2 ohm resistor and in parallel with a current source of value 2.625 amps. Okay. In parallel with, now I should be taking the equivalent resistance. There are three resistances, 2 ohm, 4 ohm and 8 ohm. But now I want actually the voltage drop across 2 ohm. So I should not be touching this. I should not be putting this into the equivalent form. I will keep 2 ohm as it is. Now I will take only the equivalent of 8 ohm. So this R, now R is equals to 4 ohm parallel 8 ohm. So this is 4 into 8 divided by 4 plus 8. So this is 32 divided by 12. Okay. 2.66 ohms. So it is 2.66 ohm. Okay. Now this 2.625 amperes of current is now branching here at this node. Okay. What is this node? This node was basically node B, and this was node D. Okay. This is node B. So now this 2.625 amperes of current is now getting divided into two branches, one in 2 ohm, one in 2.66 ohms. Now find the current in 2 ohm, multiply it with 2 ohm. That is my potential difference across 2 ohm. Okay. Now this is current in 2 ohm. Okay. So potential difference across 2 ohm is V2 ohm is equals to I2 ohm into 2 ohm. Now what is I2 ohm? It is I, this I, okay, into opposite branch resistance 2.667 divided by 2 plus 2.667. So that is I is 2.625 into 2.667 divided by 4.667. So this is equals to 2.625 1.498. 1.498 amperes. So therefore, V2 ohm is equals to 2 into 1.498. So this is nearly 3 volts. Okay, 2.99 volts, you will get it. Okay, this is 2.99 volts, nearly 3 volts. So this is how we have to move to get the solution. Okay, so the main important thing here is to shift the sources. Source shifting is very much important. Okay, so we will look into one more example of this kind, which is, this is also one of the previous year question paper example. Okay, we will solve one more previous year question paper example. Okay. Example is, reduce the following network into a single practical voltage source. Reduce the following network into single practical voltage source using source shifting and source transformation. Reduce the following network into single practical voltage source using source shifting and source transformation. Okay. Between the terminals A and B. Okay, between the terminals A and B. Reduce the following network into a single practical voltage source using source shifting and source transformation between the terminals A and B. Okay. Yeah. The circuit given is as shown. Speak. Is 2, 5 ohm, 8 ohm, 10 ohm, 3 ohm and 6 ohm. So current sources of 45 amperes and voltage sources of 30 volts. Now I have to reduce this circuit to a single practical voltage source between terminals A and B by using source shifting and source transformation. Now again I have a current source and I have a voltage source. Now let us name the nodes A, B, C and D. Okay, or continuity C and D. A, B, C, D. Now I have to shift this 45 ampere source across 2 ohm and 5 ohm such that the current should enter at node A and exit at node D, and the current contributed at node A, capital A or terminal A by this source should be 0. It means that it should enter node A and exit node A immediately. The same thing what we have done in the previous case. You can observe, okay, at node B, okay, at node B in the previous example, the current of 2 amperes is entering and exiting immediately. So the current at this terminal A should be 0 contributed by this 45 ampere source. Therefore, it has to enter and exit immediately. And it has to exit from node D, enter at node B. So that has to be done. Okay, you can take here. Now I will do it simultaneously because we know how to do it. Okay. See, shift 45 ampere source across 2 ohm and 5 ohm. Okay. Shift 30 volt source, okay, beyond node B. Shift 30 volt source beyond node B. Okay. So we do that. What we will get? This is 45 amp source. It is entering node A. So the direction of this should be towards node A. It is exiting node B. Sorry, node D. So the direction should be like this. So this is 2 ohm. This is 5 ohm. This is terminal A. Now 8 ohm. It is 10 ohm. Okay. So now this is terminal B. This 30 volt has to be pushed beyond node B. Okay, it has to be pushed beyond node B. So with this source existing between B and C, 8 ohm is at positive potential when connected to node B. 3 ohm is at positive potential when connected to node B. Now simply shift as it is. Like this. Okay. Now 8 ohm B should be at positive potential with respect to 30 volts. So therefore, $30 volts. Now 8 ohm is at positive potential with respect to 30 volt source. Okay. Now this is node B. Now next is 3 ohm should also be at positive potential. Now this is also at positive potential. Okay. 6 ohm as it is. This is 3 ohm positive at positive potential. Now the branch which is containing the voltage source originally should be replaced by short circuit. It is replaced by short circuit now. Okay. So now I can convert 2 ohm 45 amps into voltage source, 5 ohm 45 amps into voltage source, which will come in series with 8 ohm 30 volts voltage source, and this will come in series with 10 ohm resistance. And observe here, there is a very important point we should observe and act. What we generally do mistake in solving, particularly this example. I have taken this example because there is the possibility of doing mistake. Now what we do is, or what we think is this circuit is in parallel with this circuit because there is a short circuited wire. Now, once you observe from one perspective, the voltage across this is zero, the voltage across this entire thing is zero because in between those two there is a short circuit. That is what it appears. Okay, that is what it appears in this example. It appears in this example that there are two networks on either side of the short circuit, and at across short circuit my voltage is zero. Is it? This we know, across short circuit my voltage is zero. Now this network appears that there are some circuit elements connected to the right of this short circuit and to the left of this short circuit. And because there is a short circuit, we may end up in thinking that the voltage is zero across both of the case. Okay? The equivalent voltage here is zero, equivalent voltage here is zero. That is actually true as per KVL. If you apply KVL to this loop, sum of all the voltages and drops is zero. Sum of all the EMFs and drops is zero. It is true. But it appears that these two parallel circuits are connected across a short circuit which yields zero voltage. This is general mistake what students do when solving this example. But when we see from the other perspective, node B and node C is same because they are connected with a solid wire. Okay, now instead of taking it as a short circuited branch, I will take it as a common node, a single node. Okay, now I will do that. First I will convert 2 ohm 45, 5 ohm 45 amps into voltage source, then we will come there. Okay. Now 2 ohm 45 amps, it will be a voltage terminal A, this is terminal A. Now direction of 45 amps is towards node A, so the direction of voltage source will also be towards node A. I think it is too much upside. This is node A. Okay, down here. This is node D. Okay. Now let this be V1. Let this be V2. This is 2 ohms and this is 5 ohms. And the direction of V1 is towards node A. 45 amps is towards node A. So this will be plus and minus. This will be plus and minus. Direction is towards terminal A, capital A. So therefore plus and minus. That will be the polarity. Okay. So please be careful about the polarities. Now this is 8 ohms and 30 volts. This is 10 ohms. Now node B and node C is same. Now I will take a common connection. Now how I will connect to this is now this is a source 30 volt 3 ohms, and from node C, okay, from node C there is a 6 ohm resistor. So now that confusion goes off. The confusion of short circuit goes off. Okay. Now I will not mention it as node B and node C. I will not discriminate it. It is a single node. Okay, it is a single node. Now, what is V1? V1 is equals to 45 amps into 2 ohms. (90 volts). V2 is 45 amps into 5 ohms. 235 volts. Okay. Sorry, 225 volts. Sorry, not 235, 225. 225 volts. Okay. 180 plus 45. 225 volts. Okay. So now this is 225 volts. This is 90 volts. Now there is 90 volts and 30 volts in the same branch. Okay. 90 volt and 30 volt in the same branch, but these are opposing. These are opposing to each other. So therefore, we will get an equivalent voltage. 2 ohm and 8 ohm are in series. I will redraw the circuit. Terminal A. Now I will draw in a more formal form, because we know that the circuit representation is always in the form of a rectangular box or in the ladder form. I will draw in that form. It will be more easy, okay, for us to visualize. Now this is terminal A. To this, a resistance 2 ohm plus 8 ohm, 10 ohms. Okay, 2 ohm plus 8 ohm, 10 ohm. Now 90 volt and 30 volts are opposing each other. So 90 minus 30, obviously higher potential will win. So the direction will be of 90 volt, and this is 60 volts. Okay, I will come at this point here, and here I have 5 ohm and 10 ohm in series. So this is 15 ohm. There is no other voltage source. It is 225 volts. It's 225 volts. Now next, here this 30 volts. And this is 6 ohm. This is the reducer circuit. Okay. Now again we got two voltage sources in parallel, 10 ohm 60 volt, 15 ohm 225 volt. Now I have to convert that into the current source, because two voltage sources in parallel, we cannot analyze it or go for further reduction. It is difficult, okay, for us to do that. So therefore, now what I have to do? Now convert 60 volt 10 ohm and 225 volt 15 ohm voltage sources into current sources. Into current sources. Okay. Now I will convert that into current source. Terminal A. I am helpless about the background noise, okay, because it is from our house, so we can't avoid that background noise. Okay, have to bear with it. Now 60 volt and 10 ohm This is 10 ohm, and I have 225 volt and 15 ohm. Now let this be I1, let this be I2. Now see the direction of I1. Direction of I1 should be same as that of direction of 60 volts. Now which is left to right. This is I1. Now direction of I2 should be same as that of 225. So it is from right to left. Direction of I2. Okay. And I have a 30 volt voltage source. In series with 3 ohms. In parallel to this, I have 6 ohms. Slightly I have changed with 6 ohm connection, okay? But still it remains the same. Now what is I1? I1 is 60 volt by 10 ohms. Six amperes. I2 225 volts divided by 15 ohms. 220, that is 15 amperes. 15 amperes. Now this is 6 amperes and this is 15 amperes. Now I have two current sources in parallel, okay, and both are opposing each other. 15 ampere is larger current than 6 ampere. So the resultant current direction will be of 15 amperes. Now take resultant I think we can do one more thing here. Convert 60 ohm to current sources. Also 30 volt 3 ohm into current source. Because I have a resistance of 6 ohm in parallel with a voltage source, practical voltage source. So I have to convert it to current source, take the equivalent of 3 ohm and 6 ohm, then again convert it back into voltage. That I have to do. In the same step I will do now. Okay. So what I will do now here is convert 60 volt, 30 volt, 3 ohm also into current source. Because I have to do it anyway in the next step I have to do that. Now this is 3 ohm. Now let this be I3. Now what is the direction of I3? Direction of I3 is direction of 30 volt. It is from left to right. This is I3. Now therefore I3 is equals to, it is 30 volt divided by 3 ohms, which is equals to 10 amperes. Okay. Now this is 10 amperes. Okay. Here next take equivalent of 6 ampere and 15 ampere sources and equivalent of 3 ohm and 6 ohm resistors. Now these points are for your understanding purpose. When you note down and study back, you should be remembering these steps and points. Okay. Now 15 amps and 6 amps are opposing each other. So therefore equivalent current of these two is 15 amps minus 6 amps with the direction of the source same as that of 15 amps. This is terminal A. Direction of 15 amps is from right to left. So it is 15 minus 6, 9 amps. Okay. 9 amps. Now, a equivalent resistance. Let me take it as R1. Okay. I have one more current source here of 10 amperes. This is R2. Okay. Now, what is R1? R1 is 10 parallel 15. So 10 into 15 divided by 10 plus 15. So 150 divided by 25 is equals to 6 ohms. So this is 6 ohm. Okay. Now what is R2? R2 is 3 parallel 6 ohms, which is 3 into 6 divided by 3 plus 6, 2 ohms. Okay, so that is 2 ohms. So this is 2 ohm. Now convert 9 amps and 10 amps source into voltage sources. Okay. Next point is convert there are only two sources now. Convert both current sources into voltage source and take equivalent. Okay, because two voltage sources now come in series. So terminal A, I have a voltage source in series with 6 ohms. I have another voltage source in series with 2 ohms. Now direction of voltage source, let this be V1. Now let this be V2. Or V1, V2 if already we have taken. Have we taken anywhere V1, V2? No, I think. Then fine. So let this be V1, let this be V2. Now direction of V1 is the direction of 9 ampere source. So 9 amperes from right to left. So therefore right will be positive terminal, left will be negative terminal. 10 amperes will be from left to right. Left will be negative terminal, right will be positive terminal. So the direction of potential difference is like this. Okay. What is V1? Now V1 is 9 amperes into 6 ohms equals to 54 volts. Okay. And V2 is 2 ohms, 10 amps. That is 10 amps into 2 ohms is equals to 20 volts. Okay. So it is 54 volts and it is 20 volts. Okay. 54 volts and 20 volts. Take the resultant 54 volts minus 20 volts because both are in opposite direction. So 54 volts minus 20 volts. So the direction of resultant voltage source will be the direction of larger voltage value. That is 54 volts. Terminal A. So 54 minus 20. So let this be V. This is R. Now what is R? R is 6 plus 2 ohm, 8 ohms. So R is equals to 6 plus 2 ohms. And V is equals to 54 minus 20 volts. So that is V is equals to 34 volts. Now this is the single practical voltage source between A and B. This is the solution. Okay. So you need to keep a lot of things in mind when we are going into the solution, this kind of solution. The first thing what you have to keep in mind is the polarity of the sources, the original polarity of the sources or direction of the sources, and when they get shifted or transferred, what will be the direction of polarity of the sources. So polarity of voltage source after conversion or transformation depends upon the direction of current source, and the direction of current source after transformation will depend upon the polarity of the previous voltage source. Okay, so this care has to be taken compulsorily. Then only my results will be correct or answers will be correct, or else you may follow the procedure but results are incorrect. And one thing, generally when we go for evaluation, okay, we observe students will be following the procedure, no doubt, but they will be coming to the wrong answers at the end because of lack of practice and lack of focus on the fundamentals. Okay, so whatever experience I have so far in the evaluation of this subject, I came across, it is not like that students have not written the exam or written the answers. They have attempted as many questions which are sufficient for them to make pass. Okay, or even to score also to that extent. But when comes to the right answers, they are failing there. They start with the right process, but somewhere in the middle, they get lost, either by taking the wrong polarities. It may not be by intention, it may be accidentally, because in a hurry, we may, if one polarity of any of the so many source transformations and shiftings we have done, if one source polarity or direction goes incorrect, the entire solution goes incorrect. This is the difficulty of this subject. Okay, unless and until at each and every step, each and every value calculated intermediately are correct, we don't get the right answers at the end. There will not be minor deviations, there may be major deviations of the answer. If there are major deviations, it depends upon the evaluators whether they will give marks for the steps or don't give marks for the steps. Okay, so that is the reason why generally students feel difficult in this subject. Okay, so with this we'll end this topic, source shifting and source transformation. You do practice the examples on your own. If you don't get it, please come back to me. In the next class, we will look into the mesh analysis. Okay, so we'll end today's session. Okay, and in next class, we'll start with the mesh analysis. Okay, so thank you for joining the class.